Okay, guys, so we're starting this area volume unit. Okay, the first few pages of the packet, pages 1 through 5, are all just straight area problems using a formula. So I don't really want to go over those. I'd rather go over ones that are a little bit amped up a little bit of a problem. The first couple pages I want to do are pages 6 to 7 because it's area of a sector, and that is something that is new for you guys. It is not something we've done so far. So in the first few pages, you could have done like area of like a quarter circle or a semicircle, okay? But these ones is where the area you're trying to find is not something so where you know the fraction, you know it's like a quarter or a half. So like in this one, you know, on number 1 on page 6, you know you have this little piece of the circle that is only represents 51 degrees, that little angle of that wedge there. Okay, so again, it's not a quarter of a circle where you could just multiply the area of the circle by a quarter. It's a different fraction, but it's really easy to figure out the fraction because you know the angle and you know the total degrees in a circle is 360. So this represents 51 degrees out of 360. So what we can do is we can kind of do these like a proportion, okay? So if I know the area, the piece I need to find represents a 51 degree angle out of the total degrees of 360, I can find the area of that if I know the area of the full circle. So the area that I want is the small part area, right? Like if you think about this angle is the part, this is the whole, this area is the part, and I just need it over the whole area. So the whole area we could just do on the side somewhere, right here. Okay, so remember, area of a circle is pi r squared. So the radius here is 16. All we have to do is 16 squared. So what we're going to get is 256 times pi. We could just leave it like that. You don't have to make it a decimal. You can. Just remember you'd have to like over round. So you might as well just leave it as 256 pi. So again, what I have is my angle part out of my angle whole equals my area part out of my area whole. So you just make this little part to whole proportion, cross multiply, right? So all we have to do here is cross multiply. So we get 360 times x. I have 51 times 256 pi. Divide each side by 360 to get the x alone, and then you could just type this into your calculator, okay? You could use the N over D button on your calculator, that's fine, okay? It does say on top to round to the nearest hundredth, so when you type this into your calculator, you get 113.94. Now again, the units would be, so the radius was measured in feet, but remember this is area, so these units would be feet squared, okay? The next example, number 4, basically same kind of thing we're going to do, except if you realize the angle I'm given is not the angle of the shaded area. But again, because I know the total area, the total degrees is 360, I know what the rest of this angle has to be. This has to be 239 degrees, right? I just do 360 minus 126. So again, I could set up my proportion that says I have a 239 degree angle out of the total angle of 360 equals an area out of the total area. So over here on the side, I'm just going to find the total area. So this is going to be pi times 13 squared, okay? And so this is 169 pi. And then I'm just going to put that in here. So once again, I have a part angle to a whole angle, a part area to a total area. Okay, so again, same thing with the cross multiply. 239 times 169 pi, divide by 360. Okay, and we will get our answer again to the nearest hundredth here for this one is going to be 345.10. This time our units are yards, so our units for area will be yards squared. Okay, now the next one I'd like to do is number 11. Do you see there's 2 shaded areas? Okay, but here's the thing again, because what we know about vertical angles, if that angle is 46, we know this angle is 46 as well. So these 2 pieces of the circle happen to have the same area. So you have 2 choices. You could either find the area of one of them and then double it, or again, it doesn't matter that these pieces aren't even next to each other. You could still do it as a total degrees. So my 2 parts here, My two separate wedges represent a total degrees of 92 out of the total degrees of the circle for 360. So you could do it like that. If you want, you could still do 46 out of 360 and just multiply your answer by 2. Either way. Okay, again, you are given that the radius is 7. So if we side area here, we get 49 pi for the total area. So again, my part area out of my whole area. Okay, again, same thing, a quick cross multiply. Okay, divided by 360. Okay, to get rid of that 360. And then on this one, you should get as your final answer when you round to the nearest hundredth still, 39.34. Okay. These units are centimeters, so again, we're going to be centimeters squared this time. So had you just found the area of one of them, 46, you would have gotten like 19 point something, multiplied it by 2, and you would have gotten that same answer, okay? And then here on this final one, I have here, again, so I have two separate wedges of this circle. It doesn't matter. I could just combine them to be one big part of the circle. So do you see this one big part of the circle? This angle right here, do we see, because it's a straight line, is 180 degrees, plus the 58 degrees of the other section gives me a total angle of 238 out of the total 360 degrees. Okay, so you can just do that. You can total up all your angles. This one, again, side area, be careful about this. The radius, you're given 10, but that's the diameter. The radius is actually 5 in this one. So this is going to be 25 pi. So this is going to be x over 25 pi. That's it. Cross multiply. Divide. This one, again, when you round to the nearest hundredth, on this one ends up being 51.92. This was millimeters, so it's millimeters squared. Okay, so that's the area of a sector. Just do a part to whole proportion. Okay. All right, the next thing I want to go over is page 9, what we call composite area. Okay, it's where you have to find the total area of a figure, but it's not, the total figure is not a shape we have a formula for, but it's actually made up of a few different shapes. So if we look at this first example, we have an area here that's made up of a rectangle and a trapezoid. So all you're just going to have to do on this is find the area of each part separately. It doesn't matter what order you do it in. So I need an area of a rectangle plus an area of a trapezoid here. Okay, so again, remember the formula for area of a rectangle. It's all on the first page if you have to look it up, is length times width. So that's going to be 12 times 23 plus the area of the trapezoid. If you remember, the area of a trapezoid is 1/2 base 1 plus base 2. So that's 23 plus 15. Remember, the bases are the parallel lines in the trapezoid plus the height of the trapezoid. Now that's the one thing we don't have marked in, okay? It doesn't mean we don't have it, it's just not marked in. So what we do have is the total height of the figure, and then we have the height of the rectangle, which means if this is 12, this is 12, okay? Which means what's left from here to here is 6. So we do have the height of the trapezoid. It's 6, right? So then that's it. You just combine those areas. If you want, you could find each area separately, or you could type it into your calculator all at once. It's really up to you. But here, if you did it separately, you get 276 plus 114 gives me a total area of 390. Again, since my units are centimeters, it's just going to be centimeters squared here. Okay. Next one I'd like to do is number 3. Okay, so on number 3, it's actually 3 figures here, right? So I have a triangle, and it's actually a right triangle, okay? A rectangle and a semicircle. Okay, so I actually have to do 3. Again, it doesn't matter the order. I got rectangle, I got area of a triangle, and I got area of a semicircle, right? Okay. So Rectangle's pretty easy. Again, that is just normally length times width. But again, notice I've got one of my dimensions in, I don't have the other dimension in. Okay, so we have to start filling in. We got to figure out what the height of this rectangle is. Okay, so the one thing I do know is that from here to here is 9 feet. So that means from here to here is also 9 feet. Okay, but do we see that that 9 represents the radius of the circle? Okay, the one thing you should remember about the radius of a circle, it's the same radius all the way around. So that also means from here to here has to be 9 also. That also means if I draw in any other radius, it also has to be 9. So the radius I really want to draw in is the one that goes from here straight down from here to here. Do we see it would also have to be 9 feet? But what that tells me is that now I know from here to here is 9, right? If I subtract that from 26, I now know from here to here is 17. Okay, and if I want, while I'm at it, since I knew from here to here was 7, right? Now I know from here to here is 10. Okay, so we can just kind of piece it up here. Okay, so for the rectangle, I'm going to need the 9 times 17. For the triangle, so triangle, remember, is 1/2 base times height. That's why we need this to be a right triangle, guys, because we need the base and the height to meet at a right angle. So here I do have the base and the height. It's our 9 and our 10. Now, semicircle, again, the most common mistake people forget is they forget to put the 1/2 in front of the area of the circle, because it's 1/2, since it's a semicircle, it's 1/2 pi r squared. Okay, so here the r is 9. Again, you could do these areas all separately if you would like, that is fine. Or you can you could type this all into your calculator at once. If we continue to round to the 100th here, we get 325.23. Since my units are feet, we now have feet squared. Okay. The next one I'd like to do is number 4. Okay, so number 4 is another semicircle and a triangle, right? So I have to do the area of a semicircle plus the area of a triangle. Okay, so for the semicircle, again, keep in mind it's 1/2 pi r squared. The r we don't have written in, but we can find it, right? Because they gave us the full diameter. We know the r is 8. Okay, now for the triangle, that is 1/2 base times height. Okay, so that's where our problem is. Because do you see, we have this diagonal side here of the triangle. We don't have actually, if I wanted to count this as the base, I would need the height going this way. Remember, the height of a triangle has to make a right angle, okay? So if I were to draw it in, I'm really looking for this, right? So this is the height right here, that diagonal, okay? So that the thing is, I don't have it, but it's fine. I can find it because what I did is I cut this triangle into a right triangle. So do you see I could do a little side Pythagorean theorem? I could use the Pythagorean theorem to find that height right there. Okay, so here I'm just going to get, when we do the math, we end up with 15, right, after you do the math. So now that I know that that's 15, I can use that to find the area of this whole triangle. So do we see for the whole triangle, this would be the base, which is this 16 right here, and then the height is the 15 that we just found. So sometimes you are missing dimensions and you have to use information you have to find them, whether it's just subtracting, maybe busting out a little Pythagorean theorem, okay? But then when you do that, you end up with, you could type this in all at once, 220.53. The units here, they actually were not feet, they were actually meters. So these are meters squared. Okay. Now the final area problem I want to do for you is what we call shaded area, okay? Where you're given a figure and you have to find the area of a shaded region. Now, again, you will notice on all of these, the shaded region does not make any shape we have a formula of. This shaded region is not a rectangle, it's not a triangle, it's not a circle, it's not something we have a formula for, Okay, so we have to get a little fancy with the shaded region, okay? But the way we can do those is, what we do have in this figure is, do you see the entire figure is a rectangle, which we do have a formula for? And do we see this unshaded part of this rectangle is actually just a triangle, okay? So, and I do have a formula for area of a triangle. So the way we're going to find this shaded area is we're going to start with the area of the whole figure and then just subtract off anything that's unshaded. So in this case, it'll begin with the area of the rectangle, and we're going to subtract from that the area of a triangle. Okay, so area of a rectangle, like we said before, is base length times height, length times width, or base times height, however you want to do it, but I have both of those items, minus the area of a triangle. Now again, with area of a triangle, we need the base and the height of the figure. So we do know this is a height because they did draw in a right angle on that one. So we do know that 11 is the height. The base is also the same, 25 would be over here. So pretty simple, just everything is given to me. I don't have to get fancy with this one. I just have to realize it's the area of the outside minus the area of anything unshaded on the inside. Okay, so you could just do the areas separately, or you could just type in all at once, however you want to do it. But here you get 212.5. And again, it's still, even a shaded area is still an area, so the units are going to be squared units. So in this case, centimeters squared. Okay, so now this one, the area of the outside is a semicircle. Great, so I'm going to start with the area of a semicircle. Then I have to subtract off the area of the inside, which is another triangle. Okay, so semicircle, right? So here's the thing about the semicircle, right? So we need the radius of this circle, which we do not have drawn in, right? The radius would just be from the center out to here. Right? So we do not have the radius, okay? But again, there has to be a way to get the radius. And there is going to be a way to technically get the whole diameter. Because this is a right triangle, I can just use Pythagorean theorem here to get the length of the hypotenuse, okay? So when you do that, when you do out the math on that one, you get 23.4. Okay, so once I know this is 23.4, then I know the radius, this half radius, is 11.7. Okay, so now I have everything I need. So remember, it is a semicircle, so don't forget about the half in front of the formula. So it's 1/2 pi r squared is going to be 11.7 squared, okay, minus area of a triangle, 1/2 base times height. Now, I do have all three sides of the triangle. The sides I have to use, though, would be this 9 and this 21.6. The reason is, remember, the base and the height have to meet at a right angle. So those are the two sides that meet at a right angle. So those are the two sides that I need inside the formula. Again, you're just going to do out the math, do out the subtraction on this one, and you get 117.83. Since the units are, in this case, meters, I believe is all it was, it's just going to be meters squared. Okay, so the final shaded area problem. So the outside of this is clearly a trapezoid. The inside unshaded is another semicircle. Okay. So again, starting with the formula of a trapezoid, we have 1/2 base 1, we got it, it's 17, plus base 2, we got it, it's 37, times the height of the trapezoid. Well, that's what we don't have. So remember, the height of the trapezoid, I could just draw it in, would be this height right here. Okay, I could draw the height in anywhere, but it really is going to help me to draw the height in here. Okay, and the reason why it's going to help me to draw the height in here is when I draw this straight down from the end of this 17, I know that the 17 has to also go from here to here, which means what's left from here to here is 20. So I know the breakdown of this. Now, I also know it's a height, so it has to be drawn at a right angle, which means this little leftover triangle here is a right triangle. So if it's a right triangle, I can find that height by doing, once again, Pythagorean theorem. So it's going to be x squared plus 20 squared equals 25 squared. Okay, so when you do that math, you end up getting 15 for the height. Okay, so now I could fill the 15 in over here. So I have 1/2 base 1 plus base 2 times the height minus area of a semicircle. Again, it's a semicircle. Don't forget about your half before you do your pi r squared. So again, the radius is not drawn in, but what I did find is the height before was 15, which means this radius has to be 7.5. Okay, so if you don't have it, there's always going to be a way to find it. So this will give me a total shaded area of 316.64, and it is going to be inches squared. Okay. All right, so that's all the variation of the area problems, okay? So again, sometimes composite, sometimes shaded, okay? But it's really just a matter of doing a few area problems within the same problem, okay?